Check, check, check. Hello. Anybody there? Oh, my chat is broken. Herm. Chat is not working. Why? There we go. All right, cool. That works. All right, I am making a coffee, but we are going to start real soon here. I'm going to be doing some more benchmarking today. Because I want to get to the bottom of this issue of nodes versus rendering server. A lot of people are asking about that, so I want to make sure I do that justice. All right, I'll be back in 1 sec. All right, so the plan today is to push this little demo, to push it further. Because right now we've got 400 instances. I need to push this to a point where we start to see performance issues, basically. And I have a feeling we can get more aggressive with this lotting, so that's the first thing I'm going to kind of try to do. Even this first one, let's try to see. Oh, did I save this? Darn. Crap. Okay, that's all right. I did something that I didn't really mean to do. So yesterday I was making thumbnails for the YouTube video, and I actually applied the decimation. But that's not the end of the world, I suppose. And I put on display wireframes, so I gotta back myself out of this situation that I got myself into. I think I can bring back the original model without too much pain. Let's open up a new Blender. See what happens. It's my own fault. I kind of nuked things. So I always tend to do this this kind of folder structure that I really like lately, where it's like an extra. I consider it like an external pipeline. Whenever I have something that's outside that I bring into the scene, I'm calling that external. So here's the original models. Oh, I hate it when they do this. Sketchfab, right? Clear, parent, keep, transform. And then we got a whole bunch of scenes that are here. And then the final thing I did was join all these. So I'm going to join these. Nope, I'm going to join these. Copy this into my clipboard and see if I can fix this. This might make a big mess, but we'll see. Yeah, here we go. So I need LOD 1 and LOD 2, delete, paste. That's 15 ruins, 0. Okay. All right. So we're going to throw on what I have, decimate 0.5, I think. Yeah. And then I did, I called this LOD1. LOD1, and then I think this is a situation where Godot can get messed up on the UIDs because this is not, these are not the same meshes. Hey, what's up, Barryisa? 10%. And I think I did 2%. I must have done 2%. So let's see. I want to re-export this, but I have a feeling this is going to totally mess up my my meshes here. We'll see what happens. This is the existing GLTF. They're named exactly the same. Perhaps it's smart enough. Remember export settings. It's good. The one thing I wish it would remember was the actual folder name. But oh my god, my cat is just walking all over everything. So yeah, it doesn't seem to remember the folder you want to export in. So let's see, mesh modifiers, use visible, should be good. Should be good. Oh, okay. That's not the same. Let's apply some scale here. Try that again. Okay, so we're back. That's kind of cool. So these are basically 3 new meshes actually, and then Blender was okay with it. Yeah, already saving. Interesting. I remember like maybe in 4.4 it was very concerned with the UIDs whenever you would change the mesh on Blender side. So all right, I might go for even a little bit more aggressive loading. We'll see. Like the question is, like this is kind of our close range, right? If we change to 0.4, yeah, I mean it starts to get a little sketchy for sure on these things. So maybe we'll. There's definitely more like handcrafted work you could do. Is that 43,000? No, 34,000. Okay. What I want to do is I want to push it so that the geometry is not the limiting factor, if that makes sense. So let's change this to 0.5, and then yeah, you know what? We're going to do some manual work on this one. So LOD2, we're going to apply this. And we're going to clean up some of this crap because there's so much stuff here that does not actually contribute meaningfully to what we're seeing. And I'm tempted to just put on edge mode and start like deleting some edges like that. Like all this geometry is just like a giant mess. And this is where like manually cleaning things up probably helps a lot. I don't think we need all this interior stuff. Let's try to do this is going to get messy, but perhaps we can do this kind of thing. And the reason I'm focusing on LOD, you know what? I wonder what would happen if we deleted loose mesh cleanup. Oh, wow. Okay. Delete loose was a huge gain here. We're going to kill this plant. This plant does not deserve to be in LOD 0. Let's go to vertex. Excuse me. So, yeah. What are we at now? 1,200 triangles? I mean, I am positive we can get that down. You could go crazy where like basically we just want to extract this cube here and then, you know, this kind of thing. Let's just decimate it one more time and see what happens. If we throw another decimate on here and do 0.5, 600 triangles. Yeah, screw it. We're going with this. Same basic shape. That's all good. LOD 1. I'm not worried about LOD 0 because we only have like 3 of those in the scene. So 70,000 triangles. Does what work on Linux? It's Godot, so it works on Windows and Linux equally. This guy probably needs a lot of work. We're gonna do the same. I want to keep the tree. That's the only thing. So how about I want to keep these 2 trees. Because this one is going to be expensive. Let's try 0.04, 0.05. I have an idea. The rendering server? Yeah, I mean, of course, it's the backbone of rendering in Godot, so it works on all the platforms. There are some differences. Excuse me. Gotta mute myself for a second here. Sorry. There are some differences between compatibility mode and forward plus, but platform wise, it's should be pretty good. All right, let's just I feel like the tree is a visual element that needs to be retained, because if I don't, then like it's kind of sticking out. That's kind of what's sticking out to me about it, is that it's like it's kind of its own, you know, has its own fidelity. But I think the rest of this we can kind of nuke a little bit. One minute delay. Yeah, no worries. I also like don't know how to do my streaming settings properly and stuff, so half of it's on me. Let's try to delete loose on this. Mesh cleanup, delete loose. Interesting. That got rid of nothing. That's almost surprising, because this looks like a whole bunch of crap. Let's try that again. Clean up, delete loose. Oh, wow. Okay. Hello. This is now 3,000 triangles. This is 27,000. I mean, yeah, let's roll with this and let's see what kind of benefit that gives us. Okay, so there's definitely, wow, honestly, that wasn't that big of a difference. I saw like a little pop in when we imported, but I'm not really noticing anything. So now what we can do is let's run the scene first of all. And let's see. We're at a staggering 900 FPS. So 300,000 primitives. Okay. Cool. 55 draw calls. All right. What I want to do is I want to push this until we see benefits from the rendering server, basically. So we change this to, I don't know. Like, what's reasonable? 440 times 40? What's that? 1,600? We can do stats in the viewport. Yeah, you're right. You're right. That's probably faster. Yeah, so I mean, we can go up to a couple million triangles. I am streaming, so, and I'm on a kind of piece of crap laptop. So there's going to be an upper limit to what I can demonstrate here. Let's try to do 10,000. 10,000 seems like a good benchmark. Didn't really stutter there. Primitives, we're still only at 500,000. So we get that when you really aggressively LOD, you get that thing happen where it's like, you know, the more and more you add, it doesn't really make too much of a difference. And let's see. You know what I'm realizing? Something is not quite happening here the way I thought it would. Let's go back to 20 by 20. What am I doing? This should be this. Yeah. So, Bruman, I have a couple videos planned. The first one I want to address is the benchmarking. I need to try to other than showing you guys Bushcraft Survival and why I need to use Rendering Server and Bushcraft Survival, I want to continue with this example and show how eventually the scene tree is slower, right? That's eventually what I want to show you, that using nodes in the scene tree is slower than using the rendering server directly. How do you author this? You need pipeline tooling. You need asset conditioning pipeline. You need special tools that take a scene that somebody's authored and converts it into, say, a rendering server set of calls. Like that's eventually where I'm going with the videos. I think, and then I really want to do one on. There's like the comments have been really good. Partially, I feel like people have been picking apart my videos, which is fine, but also a lot of really good ideas in there. So one person said, okay, don't use LOD fading because that puts it in the transparent pass, which is slow. You need to do back to front ordering, like especially in models like these where they're totally opaque. But what we should be doing is using alpha to coverage with alpha scissor and then do dithering. If MSAA is on, then it'll fade nicely. But just to show you guys, and just a kind of sidestep here, if we turn off, if we turn the visibility range to disabled and regenerate, honestly, it's not bad. But see, now you can see the pop, right? Because there's no fading. God, like you really can't even tell though. Like let's try to make this bigger. Like how? Because my margins overlap, I literally can't even tell. What you can see though is the shadows. It goes, but you know what? That is not. That's the PSSM splits. Is the tooling free? No, the tooling would be something that you make, right? You make a tool script that it recursively parses your scene tree, converts that into the transform data, and then store that in a resource so that you can call it at runtime. Before I get to that video, though, I need to make, because people keep like kind of coming in and saying, why wouldn't you just use nodes? I'm trying to make the case that like once you have 100,000 of something, nodes are slower. And in my game, I have like up to like 500,000 trees shown in the background. And nodes are just impossible at that point, right? You can't use nodes. So what I want to do first is I got to make a benchmark to make that case. Then we'll do the scene tooling video, which I think would be cool, like in its own right, separate from rendering server stuff. And then I really want to do alpha to coverage dithering, because right now I just have the fade disabled. And let's set the margin to 0, actually. I'm curious at what point we will see noticeable flickering. That's what I'm curious. Oh, there we go. Boom. Okay. This is, we're getting classic LOD pop in here, right? See that? And you know what I forgot to do on LOD 1? I just remembered. I had a tree here for LOD 1 that I separated this selection out and then forgot to bring it back. The heck did I do with that? Oh, there it is. So how many triangles is this? 137. So we can join these. I did that in the wrong order. Bring that tree back. And I bet you we won't even be able to see pop in. So some people were worried about the... oh, you still can a little bit. You guys see that? So this is what happens when you don't have visibility fade. This is what gamers would call, oh, I see the pop in, you know, like they freak the hell out when they, you know, that's LOD pop in, 100%. We can alleviate that by putting in a margin, even without fading. So if I go clear, let's see. You still get the pop in eventually, but fade is what fixes this. Fade is what makes that gradual. If we say fade self. But people have been pointing out some like exactly what I went through on Bushcraft Survival, right? So you get a nice gradual fade here. Now, the only thing you get to see some popping on is the shadows, right? But same thing I went through on Bushcraft Survival is that like you can't control basically in this situation. Oh, I forgot to share that I was streaming anywhere. I normally get some more Twitch viewers, guys. Just hold on. I should share my stream on my Discord at least. God, can't get my crap together this morning. I have one viewer on Twitch. Normally I get a few more. Stand by. I'm going in Discord. I do have a Discord channel if you want to come in and say hi. Lots of developers, lots of gamers in there. Dev streams. Let's do a good old @devstream. More rendering server benchmarks today @devstream. Game dev? Sure. Okay, cool. We back. But yeah, so that's the plan today. I'm trying to benchmark this. I want to get this to a point where we push my GPU hard enough so that we're no longer GPU bound, basically, and we start seeing the impacts on the CPU side of things, which might be tricky. I might have picked a stupid model to try to do this with, but we're gonna do our best here. What I'm not understanding right now is why I should be generating a lot more than this. Like if I put in 200, what happens? Do I blow my... No, it's just still doing the same stuff. It's I should do the exit enter tree thing. Let's do that. You would join Matrix server only? What? I have no idea what you're talking about. No offense. I just don't know what that is. What am I doing here, guys? This is not working. It should be X in range X, Z in range Z. I'm transforming by this little grid. Okay. Do I need to, oh. Yeah. Maybe I need to instance RDs clear. I need to remove the reference to them. No. I'm losing my mind here. This should be... It's still... Oh, I'm being stupid. This is a tool script. I need to reload the scene. Control R, reload. Okay. So this is 24 million triangles. Now this is crazy. I'm probably pushing my GPU too hard here, but let's go to something reasonable. Let's do 100 by 100. This is now a big boy scene. Oh wow, there's no difference in the primitive count between going 100 by 100, which was 10,000. Okay. This is what I'm talking about, guys. So now you know what we need to do, right? We need to create a comparison benchmark that shows this is what RenderingServer is. GPU usage. I'll show you. 51 draw calls. Let's run the scene. Because we get limited info here on the stats. All right. So let's turn off the animated cam. Let's close others so make sure we don't have all kinds of stuff going on here. Because I am streaming, my laptop kind of sucks. I probably shouldn't be generating like 20 million triangles. That's upper end for my laptop, but let's push it, see what happens. I just don't want to wreck the stream is all. All right, let's go. So Debugger, profiler. We need to get also GPU usage. Objects, nothing. So what I want to show you, sure, probably high right now, but wow, okay, so at runtime, this is doing better. We're only at 7 million triangles. Guys, this is nothing. This is puny. Right, and look. You go closer, we see higher fidelity. We go further out, we see lower fidelity. Loading is powerful. Loading is crazy. Okay, task manager it is. So I'm definitely, but like, I don't know how much of this is streaming, right? I've got a video and code. Okay, 10%, that's not bad. 3D, 75%. This is a laptop 3050 Ti, which is not like a 3050 PC. It's kind of a, to be honest, kind of a crappy GPU, if I'm being completely honest. Cool. So now you know what we have to do. We have to code a node-based benchmark. So imagine there's 10,000 nodes in this scene, right? So this is rendering server. Rendering server, you just pump them out, and then the GPU is like flying. So, okay. All right, so now I must go back to my nodes scene. All right, here's my nodes. And we need to change this. And this is where we're going to probably see my computer break. I think this should be fine. Oh, but you know what? Here's the problem. Here's the problem. Okay, quick recap. For those who don't know. Right now, we are using a manual LOD approach, meaning generate LODs is off, right? If we look at the GLTF file, generate LODs is off. So Godot's auto LOD, which uses Mesh Optimizer, is not kicking in. In case you're curious, Mesh Optimizer is not aggressive enough on a scene like this. It just like, it does not push the decimation far enough to be useful. So what I did in Blender, I just cranked down the decimation, and I also did some more manual lodding. So we got 600 triangles here, 3,000 here, and then our big boy is 27,000, which is like still unnecessary, but whatever. So how many triangles are in this scene right now, actually? Because I think these are all fully rendered. Yeah, this is 11 million here. So you know what we need to do? We need to fix this. Let's fix this. We're just going to clear these for now. If you have not done this already, when doing the benchmark for the multi-mesh, can you use multiple mesh instances? No. So that's not. I know that would work. First of all, multi-mesh chunking I know that that's good, and proton scatter might be a good benchmark to compare. One second. Let's turn this off. All right, sorry. No, I did not get swatted, guys. I am having some. I normally stream at home, and I normally have my camera on, but I'm gonna have my camera off for a little bit. Did anybody work with Proton Scatter or comparison tool? Yeah, I mean, maybe I'll get to that, but like I said, that's not my main intention. I know multi-mesh chunking is good. Multi-mesh chunking is very hard to manage. I do, for the record, I do multi-mesh chunking in Bushcraft Survival. I could show you that if you're curious. Maybe later in the stream, I'll show you how I do that. Multi-mesh chunking is great for, you know, I have LOD 012. Imagine you had LOD 4, right? Which I actually have in Bushcraft Survival. I have LOD 01234. And LOD 4 are multi-mesh chunks that are in the background that have the correct AABB. And then they have the correct like frustum culling as a result of that, right? So, all right. So what I need to do, because right now the problem is this does not use. One sec, guys. All right, sorry about that, guys. Yeah, so what we're trying to do right now is I'm coding some, I'm trying to code a benchmark, right? So just to recap, I have this rendering server situation. This guy can pump out, this is 10,000 instances of that building, right? Which look like almost nothing from this height, but we get about 20 million triangles. What we need to do is code an equivalent scene in using nodes. And I want to show people, because I'm getting lots of comments of like, why would you use the rendering server, right? I'm getting a lot of pushback on that. And yeah, I know the node system is good, but like, once again, like, we're not even talking about occlusion culling. We're not talking about anything complicated. We're just talking about rendering server and frustum culling and LOD. That's it. There's more stuff you can do to optimize, but this is pretty intense in terms of, you know, the level of optimization you get. So the question is, if we clear that for a second, if we generate the same grid in nodes, right? If we generate the same grid in nodes, how does it compare? The problem I have is we are now using manual LOD. Generate, if we look at this, generate LODs off, right? Generate LODs off, and actually I can do camera back on for a bit here. So let's do, all right, I'm back, sorry. Now we need to use visibility ranges. Okay, so what am I talking about? In the mesh instance 3D, there's this, right? Begin margin, end margin, fade mode. Exactly like what we did with rendering server. Exact same thing. But now I need to do this with mesh instances, which I don't think will be too hard. So let's do this. Let's do, how am I going to do this? So we're going to bring these variables out, just like I did with the other one. We're going to create I'm just going to pass on this for now. I don't want to run that animation. So we're going to do, what do I call it? Generate buildings. Let's use the same signature, right? So we're going to do the same function, but now this is the node approach. So all we need to do, I think, is new building, visibility. Sorry, my keyboard is off center here and I can't type. What's annoying is that in the rendering server code, they call all of these things different variable names. I think begin is going to be min, max is going to be end, What else? New building. We got to put in the margins, right? And end begin margin equals min margin. End margin equals max margin. Okay. And what I'm going to do, just for apples to apples, we're going to set the fade mode to be disabled, right? So this is the most efficient way to do it. We're going to change this to disabled as well. This means we're not using the transparent pipeline whatsoever. Like I said, for those of you coming in a bit later, my plan with this video series is I'm going to be, I want to do alpha to coverage. People do not realize how overpowered alpha to coverage, alpha scissoring is, especially if you have MSAA on. So, okay, so we're going to copy this. We're going to put this in here because it's going to be the same code, basically. The only difference is, we need to bring in these guys. We need to what am I doing here? Generate buildings. Why is this complaining? Oh, I don't have my variables. We're going to do that. We're going to change this. We're going to change this to this. Right, so we're going to clear all the nodes, generate the LODs. And then we just do that here. So when I'm generating, I'm going to do gen all. We can just do this. All right. Like I said, I don't want to do the animate cam for now. I was thinking about opening a proposal for every scene, opening the editor to have its own World 3D. Yeah, that would be really nice. Agreed, 100%. I'm wondering if that would cause Godot to freak out, because my understanding is that each World 3D is tied to a viewport currently. And if you had independent viewports, that would probably cause the rendering system to lose its mind. All right, that didn't work. Oh, we need to reload the tool script. So by the way, I'm doing some stuff a little quickly here. I have Control R bound to reload the scene. So nice thing when you're dealing with tool scripts. Okay, so here's our buildings. This is not working whatsoever. So let's do this again, but let's just generate LOD 0. There we go. Okay, it is working actually. Okay, so here's our LOD 0. Seems fine, right? Let's put in our LOD 1. I'm just going through to check to make sure this is actually working. Here's our LOD 1. They pop out as you get closer. Right, seems good, seems reasonable. And then let's put in a LOD 2, just make sure that is good. I should have done this benchmark in the previous video, but I don't know, just ran out of time. All right, so there's our LODs. This is not right currently. How is this many primitives? That is not pulling the right mesh. No, it is. I feel like these stats are, there's no way, right? Is this using the wrong mesh? Oh, I know what I did. Okay. We missed one parameter. This is not currently being used. So we're just going to set this to mesh. This is why you test things, guys. This is why you test shit. All right, there we go. Now we're down to 200,000 triangles. Okay, better. All right, so we bring this back. Reload the scene, generate. All right, so how do we achieve this? All right, so this is the same. This is now apples to apples of doing 20 by 20 here. Oops, no, that's not what I wanted. Clear, reload, generate. There we go. Okay, so we should see everything being equal. We should see 283,079. we're going to have that annoying thing where we need to clear them here, and then we go here, and then I am getting a higher primitive count here. Don't know why. I mean, it's within the ballpark, 289,000. You guys can't see the stats? All right, let me turn off my face. You guys don't need to see my head. All right, so 300,000 here versus, once again, this is super annoying. I should do the enter exit tree thing. How about this? How about at a minimum, let's put in exit tree. Exit tree, clear. What do I call it? Remove buildings. So does this actually work? If we go generate, let's reload the scene, generate, and then, oh, it does work. Okay. That's what we should do. Because of the node itself, it's right here. You guys can't see this? Yeah, it should be, primitives are right here. So I'm getting 300 and it is based on distance, right? Oh yeah. It's very dependent on where the camera is. So we're in the right ballpark, right? 300,000, 8 draw calls versus, 300,000. We got some more draw calls here. Interesting, actually. I'm not sure why we're getting more, but once again, it's heavily dependent on, that gizmo was giving us 8 draw calls. Okay, so we have an apples to apples comparison now. So the question is, does my computer blow up when I try to generate 10,000 of these instances here in nodes? And I'm betting that it will, and the stream might crash. So let's try that. Let's try it. Everyone cross your fingers. How about this? How about I do camera over here? Can I move that? Okay. You guys don't need to see my file tree anyways. Okay. Good luck. Yeah, we might be restarting here in a sec. And now we wait. Okay, never mind. We're still doing 20 by 20. Let's reload. And let's do generate. And we're still doing 20 by 20. What happened? Oh, we need to set this to 100 by 100. I should export these. I'm just being stupid. I'm just being a dummy. Yeah, so let's set this to, all right, now we wait. And it's this is what 10,000 nodes looks like, folks. Non-responsive Godot editor. I mean, this is what you expect. The editor has to do a lot more processing on nodes, so I get it, But this is so the next video is going to be answering all the naysayers. Nodes are great, right? Nodes are great for level design. They're great for doing stuff, but you have big scenes. Just imagine these are different meshes, right? Imagine this is a big scene. Imagine it's not a grid, but it's something somebody offered. You could easily have 10,000 objects. That's not crazy. It will work. I think it will. It's just we're waiting for the scene tree to populate right now. And by the way, this is not 10,000 nodes. This is 30,000 nodes because there's 3 levels of LOD, all with their own visibility ranges. So now you see like these things stack up, right? Yeah, I hope it works because I'd like to run my benchmark. The other thing is that I don't need to do this in the editor, really. Like I can just do this at runtime if I really want to, if push comes to shove. All right, folks, we're here. This is what 30,000 nodes looks like. Not bad, actually. 10,000 objects. That's just the GPU side of things. When we say object, that's the GPU context. But I'm scared to scroll here a little bit. Yeah, here you go. Here's your 30,000 mesh instances. Oh, even hitting hide. I've never seen the editor quite so slow, actually. But yeah, so this is not quite fair yet, right? So this is just editor performance. It's not, you guys saw the rendering server 5 minutes ago. The rendering server handles 10,000 instances like nothing, like no big deal. So I don't even know how I'm going to do a video on this because we're just going to be sitting here watching a little scroll wheel go by. So this is fun. What else can we do in the meantime? So how would you build your world then? Yes, I hear your question. I understand your question. I'm getting to it. Basically, you need, we can. So here's the plan. All right, let's do this. We'll take a step back while while Godot is losing its mind. I have this modular kit that I found on Sketchfab, which, believe it or not, has an open source license. So people are always making cool shit, putting it out there for free. What we're going to do next video, or a video eventually, we are going to develop a scene with a whole bunch of different models using all of my artistic instincts, which I don't have many, by the way. And I'm going to write some tooling that converts this into data that the rendering server can consume. And we are going to make a ton of these models. I'm going to make like close to 10,000. And you know what? We might use some geometry nodes to like scatter it all over, right? I did in a past video showing how you would instance geometry nodes properly so that when it comes into the editor, it actually instances properly. And then we'll write a tool script to convert all that data into a resource that we can save in the editor. And then we can load that resource at runtime and then let the rendering server just like plow through it. That's what I'm building up to because, I think people have responded to the videos pretty well, but I get naysayers just being like, well, why wouldn't you just use nodes? Why wouldn't you just use nodes? And what we're talking about is huge worlds where you step on a mountainside and you see a city in the background, right? You can't occlude that. You can't magic it away. You have to get back to like the basics of rendering, which is LOD, frustum culling, occlusion culling if you're lucky, but I'll be honest with you, half the time I don't think occlusion culling is worth it. So yeah, we're just using the basics of modern 3D rendering, which is frustum culling and some good old LODing, right? I really shouldn't have hit hide here. I don't know why I did that. This is what it looks like when your CPU is chewing through 60,000 nodes. Okay, that took forever. All right, now we turn it back on, and we had to wait again. So don't know why I did that, like I said. So yeah, that's the plan. We're going to make a scene in Blender. We're going to, like I said, geometry nodes. That would be some cool stuff. We'll see how that instances out. And then we're going to write some tooling to convert it into rendering server. And you're going to see, I think that video is going to be cool because like, I don't think a lot of people are seeing that kind of thing on YouTube where it's like, we're going to make a little fictitious scene with a little terrain where a little dude is going to be standing on the mountainside, and we're going to look at it like a whole city of like, destroyed buildings, which is like, I didn't intend for them to be destroyed buildings. I'm not like making a statement about that. It's just like, imagine a city that has destroyed buildings. Yeah, and we'll see it. It can do it. Like my laptop is going to be able to do it. Most people's can run it. Like with the right level of loading, you can make this thing run on basically anything. I think people have lost sight of that, right? Throw some FXAA on. And I want to show, dithering, using alpha scissor with dithering. Like, I guess developers probably don't know two things. Some developers do because they're in my comments. But like, one is that alpha rendering, full alpha rendering, and depth prepass are very slow. Okay. Two is that they're slow because you're in the transparent pipeline and you have to sort things back to front, basically. The second thing is we can get around that by using alpha scissor with alpha to coverage. I'll show you throw an MSAA. It'll look good. It'll surprise the crap out of everybody. Do you plan to build out scene in Blender or in Godot? We're going to build it in Blender. And I'm going to drag the tscene file in. We're going to write a tool script that takes all that, iterates through it. It'll probably be slow, just like this is now. and then saves that data as a resource. And all we're going to do is we're going to save all the transforms of all of the meshes. We're going to save their mesh name. We're going to write some automated scripting that does their lotting for us. And then that's it. I got a little bit of work ahead of me because I'm going to manually lot all these buildings, but I'm going to do the same thing, right? Like what I'm going to do is take this building, for instance, we're going to duplicate it. I'm going to call it 16 lod 1. I'm also going to call the mesh that because I'm extremely neurotic like that. Right? And we're just gonna decimate. We're gonna decimate this to 0.10, or what do we do here? I think we did like 0.05. And I'm not gonna get too crazy with it, right? We're gonna decimate maybe even 0.4. We're gonna do one more. We're gonna call this lod 2. And I'm gonna build out my little kit here. 0.01. Okay, that's obviously too far, but 0.02. Right, 800 triangles, 700 triangles, great. That one's done, easy. And actually, let's move these to a new collection. Let's move these to LOD meshes. So that's the plan. We've got some more videos coming. Hopefully I can do the videos in the next couple of weeks because I won't be able to, or the next week, I won't be able to record over Christmas unless I take my mic and everything. I don't know. I'm still debating that. How would you handle collision shapes? Yeah, so like same deal, right? Physics server. We have a lot of options with that. I have my own pipeline. Some of you might be aware that I have a pipeline. And in that case, I'll give you a for instance here. Let's hide this stuff, right? So we have our LODs. The way you would author collision shapes for this, if you want to be smart about it, is you would do something like you would have a cube. You could do something like this. We do something like this. Maybe shrink wrap. I don't know. Right, we would get like the rough bounds of the object. So here's our bounding box cube. And then we would finesse the edges and stuff to get it better. I actually don't even like how I did this. What would we do here? Basically, we would manually author the cube collisions, right? I mean, we could do some convex hull probably, and it probably wouldn't be the end of the world. But you want things to be pretty good, right? Performant. We all care about performance. Presumably, if you're in my channel, you care about performance. So, like in this case, we would probably do this. And in the pipeline, the way it works is that you don't actually need to author these shapes. You just do extrusions, right? There's your collision shape, I think. Yeah, seems reasonable. And then we would, you would just separate by selection. So we would do a good old P. And here's your two collision shapes. So eventually what we'll do, we'll have a shapes for new collection collision shapes. Right, and we go through and we author them. And then we'll bring this into the pipeline as well. Don't shrink wrap Godot convex algo is good enough for that. Add call to the name of the object. Yes, I'm aware of how import hinting works. When you're talking about this many objects, convex hull collisions are going to slow the engine down like crazy. We need to use primitive collisions where we can. I'm encouraging developers to stop making severely unoptimized games. I don't think it's doing players any favors. So, yeah, we could use the convex hull collisions, but well, in this case, it wouldn't be very good. I want the player to be able to walk around this little debris area. A convex hull, right? Let's do a little test here. let's do, there's a way to do this in Blender, by the way. You can do mesh. How do you do this? I forget. There's a way to convert this to a convex hull. Convex hull? No? Convex. What am I looking for? Oh, we got to be in edit mode. Convex hull. There we go. This is what a convex hull would look like, right? So this is what your collision shape is going to look like. And in our case, you tell me if you think this collision is very useful, right? Player can't walk into this little area, you know. For the record, I know that convex hulls are reasonably performant, but like if you look at how many triangles are here, Godot's doing a very similar thing, by the way. Yes, it's optimized, but you're still going to have this many triangles. Multiply this by 10,000, and I think you're headed for pain and suffering. All right, I'm rambling at this point, but here's our LOD. So that's the work I got to do. I might do that on stream. Who knows? We'll see. For now, we're trying to run this benchmark, right? So let's run this benchmark. We're saving this. We're going to see what kind of FPS we get. Yeah, so 160 FPS. Maybe that's not bad. My processor is starting to heat up over there. Yeah, it's not horrible. It's pretty stable, actually. All right, so 130. I don't know. Let's compare. Let's see what happens. It's the editor performance, I think, is probably the biggest issue. And perhaps that's enough to make it worth doing the rendering server. So let's close down this scene, because this is chewing the resources right now. Yeah, I can't do much with Godot right now with this many nodes open, so task manager, please. All right. My computer is doing okay. It's Godot is locking up, right? So it's stuck in a loop. It's stuck in a big old for loop. It should probably, we'll say, not responding. Yeah. So this is what happens when you none of this work is done on threads in Godot. There's no task queuer. This is just good old C++ programming chewing through, 70,000 nodes. I guess what the point is that I'm trying to make is that there is overhead associated with nodes. Yeah, CPU is the bounding factor in the node tests. We'll see. This may not even be really enough to catch the difference, but we'll find out. If it isn't, then I may have to show you Bushcraft Survival and why I ended up doing it that way. I was hoping to come up with a little scenario that would benchmark this somewhat nicely. Okay, that's closed. I'm actually tempted to reload the project because I'm hoping that's not all still loaded in memory. But let's just run it. So we got about 128. We got to redo this scene quickly. What I'm going to do, I'm going to put these on exports. We're going to turn off that. Why is that playing? That's weird. Let's reload, and then let's do 100 by 100 generate. So the first thing to notice is you get no editor lag whatsoever, right? So I mean, that in its own, you got some artists working on your game. You want 10,000, 30,000 nodes in your scene, or do you want, like, we're flying here. This is nothing, right? 10,000 GPU instances these days is not really a big deal, basically. And let's see what we get. So, yeah, I mean, maybe about the same. We got about 30 FPS, but, like, does 30 FPS matter to you? Right, so before we had about 120 FPS. Let's, increase this. Right, so we got up to 200 FPS. So in this scene, I would say the profiling is showing at least a 30 FPS improvement. with a bigger improvement on the editor side of things. You know, once we're not looking at all the instances, we're getting huge improvement. Before, I don't know if you guys, maybe I'll do a screenshot, but on the node situation, we were capped at like 120. It didn't really go above 120. So the rendering server is just making very light work of all of this. Of course, if we show everything, then we drop down a bit. But there's no scene tree interactions here. So if you look at our object count, our nodes are nothing. My computer is not really suffering here at all. So yeah, I think this is what I need to do with the next benchmark. And then I got some video ideas after that. Like I said, right now we're doing the more efficient. Actually, you know what? I just realized. Yeah, okay, never mind. We do have a margin here. So we have fade is disabled. I just want to confirm fade is disabled on both. Yeah. So we're not doing fade. This is all good. Yes, yes. You guys are so harsh. I've done videos on VAT. Do you know what VAT is? Do you know what vertex animated textures is? I have rendered 100,000 animated zombies in Godot using their own state machines. I know you want animated skeletons. I know you want to be able to edit the scene. What I'm showing you is, do you want to have an absolutely huge city and have it run on most machines? With the auto versus manual test, was that also 4.5? Yes. 4.6, I've heard has some more LOD pruning. So that would be great, right? If their auto LOD is better in 4.6, that could be huge for workflow. We don't have to do all of this. Like, think about all the work I have ahead of me just to do the manual lodding, right? But 10x is still not enough, for the record. 10x is not even close to what we need. My LOD 2 has 700 triangles. My base mesh has about, in this case, the base mesh has 27,000. If we bring that down to 10x, 2700, we're still off by a factor of 3. Animated 2D or 3D? Go check out my channel. It's 3D. It's 3D, right? Here. Let's pull it up. But yes, VAT is another serious optimization you can do to have. You want to get 100,000 animated meshes. Right? And so actually, this is not even the first video in the series. This one talks about the multi-state animation. But these guys are all VAT. They all have their own state machines, right? Let's find the other VAT one, the first one. Where is that? Here, part 2, part 1. So yeah, this is like literally, this is a walkthrough. Like, look, I did a test at the beginning. This is what 100,000 animated dudes looks like, right? Nothing, no performance cost practically. Multi-state animations. Scene building, yes, I'm getting the same question over and over and over. Yes, we're going to do scene building. We're going to do some pipeline tooling, and we're going to show you how to build a scene out and do this kind of optimization. Part of this series is 10x is less than the oldest, smallest LOD. No, untrue. 27,000, 10x reduction, that's 2,700. This one is 622 triangles. So no, it's not. It's not. And like people rightly pointed out, you know, artists would take this down even further. You see all this crap? We don't need this. So anyways, take it with a grain of salt. I know 4.6 4.6 is probably going to be a huge improvement, and I'm definitely looking forward to it. But at the end of the day, if you have these utterly massive cityscape scenes, your lowest LOD or your highest LOD, depending on the way you look at the numbers, it needs to be like sub 500 triangles. In Godot's example, yeah, perhaps. So we'll see. Maybe I can do that test when that comes out, right? For now, I'm rolling with 4.5. I think that's probably what a lot of devs are on. So I need to title my videos better. Was looking for this. I'm not good at like the YouTube algorithm and like thumbnails and stuff. So, but yes, this is where we're going. I got some work to do. I could probably do some of it right now. I'd say I'm probably going to stop the stream in about an hour, but I think I'm happy with this benchmark, right? Like the node test is like kills your editor, first of all, and we lost significant FPS. We were capped at about 120, and that shows you we're CPU bound. The reason we're capped at 120 is we had 60,000 nodes, and the CPU process time is what's holding us up. The GPU is changing, right? The reason the rendering server is giving us this bump is because, like I said in the first video, like frustum calling, lotting, the GPU is just like chugging away, doing its thing. There's very little CPU cost. We are just like operating on things in a straight line array and that kind of thing. So, yeah, how would we approach this? I don't know. Let's start to think through it. So let's do a new scene. And I want to show you perhaps, I mean, we could go two ways with this. We could go physics server next, or we could go tooling side next. Let's call this scene tooling. All right, so we're going to, I want to use probably geometry nodes. And let's assume for argument's sake we only have these two meshes. We'll start with something simple. Let's get some axes in here. Let's get a grid, perhaps. Okay. So we do a big old plane. I can't remember if you need it to be subdivided for distribute on points to work. I'm not sure. So let's do, we're going to do an Alt D and move this to scene. Okay. Now I'm really going to test my knowledge of geonodes. I don't know geonodes like off the back of my, you know, I'd have to look something up here. But I think we want to do like a distribute on sure. And we need to get like the object data, right? Isn't that how that works? Object info? Something like this. I can't remember. Did a video on this actually. Just have to look at my own video. 4.5 probably better until 6 is stable for benchmarks. Yeah, so like I said, once things are stabilized, I'd be happy to do a benchmark with the AutoLOD in 4.6. I mean, that's something that I've been kind of not happy with in Godot forever, and I think a lot of Godot devs don't realize how shallow the AutoLODing currently is. I mean, for people who are doing like low poly indie dev, whatever, that's fine. That's really not a big deal. But I need to do this. What did I do here? Distribute points on faces, geometry goes in there. We put the density and the seed as an input. Instance on points. Okay. That is what I'm missing. Instance on points. And then we go instance. Wow. Okay. Density. Oh, you know what I need to do? I need to apply scale. Oh, hello. Okay. Uh-oh. Oops. Crap. Oh, okay. We just need to hide that. We just created like a million instances of this guy here. So let's reduce this density to 0.01, even 0.01 perhaps. Is this stream still going? I gotta do this like GPU intensive things while on stream. Right, so even this is kind of wacky. Let's do 0.005. Okay. How do I spread these? I need to like, I don't know how to use geometry nodes. Instance on points. Can we do a random? Is that not possible? It's getting a little slow here. Oh. Yeah, I saw that in the Blender. My Blender just crashed. OBS is probably soon coming after. Now here's the question. How much did I save before it crashed? Scatter modifier? Yeah, that would be cool, eh? I saw it in the the Blender release notes. I'm like bad at saving stuff when I'm on stream. I'm normally not bad like in my normal life. But apparently I'm bad at doing that on stream. I don't know. I kind of want to just manually author it, but I know that's a really dumb idea. Let's try this one more time. So let's do a plane. We'll start with this kind of deal. Let's do on that floor, 3D cursor, origins. Okay. And we're going to hide, I'm going to hide everything except this guy. And we're going to try to do this again. And you know what? Maybe let's work with LOD 2. We have the LODs. Let's do that. That would be smarter. And so let's move this to scene. This time I will save it. Hide that. Okay, cool. If we add a modifier to this, if we add a geometry nodes, does this add it to this one too? No, okay, good. That's good. Okay, attempt number 2. Object info. Instance on points. Points goes from the geometry. Instance comes from this. Density. What am I missing here? Distribute points on face. Yeah, distribute points on faces. Okay, this should work a lot better because we're working with a lower LOD here. Except it didn't work at all. Awesome. Love it. Let's apply rotation scale. There we go. Okay. Isn't there a way to get these to distribute like so that they don't overlap? How do I do that? Wow. Okay. Hello. Okay. Yeah, this is the Poisson distribution dealio. Physics server is probably better for managing lots of collisions. Oh yeah, 100%. That's what I'm working up. That's what I'm working up to. I think we need this to be. So, yeah, here we go. So this is how we're gonna get some control over this. So we're gonna do 0.1. They still overlap sometimes. So I think what we need minimum distance minimum. We got to do. There we go. Now we're starting to get some more control over it. Density factor 0.1. Okay, cool. All right, so we can get some. We need to increase this still a bit more. And density factor 1. I guess you just end up with you just end up basically with a uniform distribution. That's not really what I'm looking for. Okay. I'd like to like snap the rotation to like 90 degrees. Can I do a random? Is there a random value? Oops, let's do that in, I don't want it in rotation. I just want it in the Y component. Can I not feed? How do I do this? Isn't there like combine? Yeah, here we go. So let's do this, and we'll put this into Z rotation. Is there a way to like snap round? Snap. Oh, oops. Let's snap it here. Yeah, it is Poisson disk. What would be pi over 2? What's pi over 2? That would be 180 degrees. I want pi. What do I want? Yeah. 1.57. There we go. We get some random snapping. Cool. And I want to reduce the density because I want to introduce other buildings. But yeah, this is where I really should use the scatter. Oh man, I really want Blender 5. Should I just bite the bullet and get it? Or find some sort of like Blender add-on that can do this for me? Because this is going to be painful. I want to do like this kind of distribution, but I want to do it for multiple objects. Can we join? Yeah, there's not going to be a way to do that, is there? Because they're going to overlap. Okay, that's perhaps better, right? We'll do something like that. If I did the same setup on the other mesh, right? So we bring back our 16 LOD 2. That guy's here. And Alt D, move to scene. I'm going to save this time so I'm not an idiot. And let's drop in the geonodes. So yeah, the problem is there's no way to make sure these don't overlap. I don't think. Yeah, like right here. You know what I'm saying? But whatever. Let's assume we have some kind of workflow like this. Then all we need to do is we need to export GLTF. And we're going to export them to, we're going to call the city scene. Now, there's a setting you need to make this actually work properly. We need scene graph. I think it's one of these. I think it's this. This finally works. Fun fact. This didn't work up until like 2 versions of Blender ago. But if we, this is another thing that could potentially break my computer. So I apologize if the stream abruptly stops. Yeah. No, I got it. I've used Proton Scatter before. I'm aware. Proton Scatter is good. I don't have any issues with it. I just I want to get down to some of the fundamentals and explore how this stuff works. All right, so let's do scenes. Let's do city. We're gonna make city scene. Where did that go? Where did I just export this? Oh, the wrong place. So models, assets. Yeah, let's do city. I'm going to call this city.gltf. Okay, so we're going to get this. It's going to do some unnecessary stuff because we're going to get, you know, that texture again. But what I plan on doing is mapping this. We're going to have one file that's like all the LODs just saved as meshes. And then the other file is going to provide like a mapping. So the cool thing about this is that if you take a notice here, this is all instanced properly. City mesh, city mesh, city mesh. They're using the same underlying mesh. But you know what? I just noticed this has a weird name. What? I don't really know what it's doing here, but whatever. We'll see what happens. So let's go to city. Let's do a new 3D scene. And let's just drag this in, see what happens. All right, cool. So here's our LOD2s. Pretty performant in the editor. Of course, we don't have any detail. They're basically devoid of the detail that we had before. For the most part, they have a lot of these sketchy little stuff happening there. Okay. So the only thing you need to do, right, in a tool script, what I would probably do in this case, because I don't want this tool script to like run as a part of the whole thing, let's do a, I want to call it scene process, right? So we'll call this scene process. Make it a tool script. Shouldn't have anything in ready, shouldn't have anything on process. And we'll just do, export var. It's a bit redundant. We can get the parent from the scene tree. So now we don't really need that. Let's do export button, tool button, parse scene. So the general idea, right, is you're going to have a recursive scene function. And we want it to be just a node because, you know, if you hit an animation player or if you hit something that's like a node like this, you need to account for that. For C in node get children. So we'll do this kind of recursive thing. Now, by the way, before people, going to jump at me here, you don't typically do this kind of recursive stuff at runtime. But in a tool script, who cares? It's in the editor. It's fine. How about this? If node is mesh instance 3D, for now, let's just print it. See if this works. We're going to iterate scene on get parent. Okay. That's the idea, right? So we're going to reload this, and we're going to pull up this and parse the scene, and there you go. So here's all your mesh instances, right? The idea would be you store all of these into a flat array, and we want to pull out something like, I don't know, the mesh name. We could perhaps link it to the mesh name. So we can do that too. What we ultimately need to do is save it as a resource in the editor. And we want to kind of think about that. Let's just call it data. And what you would want really is the transforms of all of these. So for instance, you could also print the node.transform. And let's just take a look here. So we want this data. What else do we want? We would want the print node.mesh. Okay, so here's your array meshes. Let's get the resource name. City mesh. There's something weird going on here for sure. If you take a look at our output, half of these meshes are city 15 ruins 0 lod 2, and the other half just say mesh. So what is happening here to do that? Because this doesn't really make sense currently. It might be because this has a decimate modifier. So for instance, if we go look at lod 2 here, and let's just apply that. Yeah, so let's do this. If we do, we're going to make this unique. All right, so this is now unique. Then we can apply this here. And we should be able to switch this back. Maybe. I don't know. We'll see. Don't know. Oh, wow. Okay. Hello. What? That's not right. I want a geometry nodes. Okay, there we go. That's better. Yeah, so I really don't know what's going on here in terms of the mesh names. It's probably that Blender feature, right? Let's go Blender file. Let's take a look at this. I think that got a little messed up here. Might be something in these export settings. Include visible, transform data, scene graph. Okay. Wow. All right. It's doing some real weird stuff. So this is going to make parsing the scene a little bit more annoying, because right now our meshes are unintelligible, basically. Are our object names still correct? No, they're not. So there's lots of issues here, right? So basically what we need to do in order to like actually make this a proper like pipeline tool is you would need to map these instances need to get mapped to the proper. Oh, okay. There's something weird going on here. Oh, I see. Oh, okay. We're just gonna give this a suffix. See if we can get this worked out. All right, so if we try this again. Yeah, all right, so we got something to work with here. What we can do actually is we can get the nodes get parent name, right? It's a little hacky, but it'll work. So what we do now. Yeah, so if you guys are still with me here, the idea would be you parse your scene tree recursively, and you grab the transform of each object, and then you grab the mesh. So we can map these object names to our ruins here. Obviously, we don't need LOD 0, so we can get the LOD 2x out of there. We only need the 15 ruins 0. Like this part of it maps to these mesh names perfectly. And then we can do all the programming behind the scenes to actually create that pipeline and yada yada. So I don't know. So let's keep going. If we were to do this, I forget how to do this in Godot, but if we were to what I want to do is I want to save like a custom resource, which is just we're going to use resource saver. Okay. What's the best way to do this? I mean, obviously we could just do an array of dictionary items, but that seems kind of silly. But perhaps that is fine. Right? So what you would do is we would construct we would do something like this, where we would have our data looks like that, clear it, and then data push back. It doesn't need to be pretty, right? It's just for the editor as of right now. You could probably find ways to make this more efficient at runtime, but we'll see. So we would do transform, and we would do mesh key node get parent name replace. We don't need the underscore LOD2 underscore x. That part is unnecessary. Replace that with nothing. So then we just need to do resource saver, save, resource. I think you can do this on arrays, can you? Path, and then we'll just do, we'll give it a path here. We'll give it data instance data dot tres dot res. Tres, res, let's do res. Oh yeah, how do you do this? I did this in a project before, but I forget how. Godot save array as resource. 2021, this is going to be Godot 3. Uh-oh. Less ideal. You could do an importer script that would parse it on import. Yes, you could. I've done lots of those. I'm liking those less and less as time goes on because you have less control over when they run. And when you open the game, all your GLTFs import, and then if it detects even a little change, it tries to re-import, and then if the scene's not open, you get all kinds of issues with that. So actually recently, I've been opting for a simpler process where you just control this by hitting this parse scene button. Just a personal preference of mine. So we're going to do, I hate this, but we're going to do a little thing here. We're going to make a resource. We're going to call it instance resource. And it is just going to have a single variable. I think it needs to be exported. I think instance data is just an array. So it's kind of a little bit of a hack, I guess. We're going to we're going to give this a class to class name instance resource. Oops. And then we can do var instance resource equals instance resource dot new. This is a little bit redundant, but whatever. Instance resource data equals data. And then we save this. All right. Yeah, let's try it. Hopefully we don't blow up the my editor here. Uh-oh, that doesn't seem good. Oh yeah, that totally crashed Godot. I can't remember how to do this in the editor. Save Godot, saving resources in the editor. Anyways, I probably should do most of this dev off stream. Oh God, yes, we need structs in GD scripts. That's like, yes, we do. But that's a side note. Maybe my issue here is that I'm trying to save. Why is this not working? Instance resource. Does this need to be a tool script as well? I'm skeptical about that. Oh, okay. That was it. All right. Your resource needs to be a tool script. There you go. All right. So how does this play out then? So we've saved our data. Yeah. I think I'm a second ahead of the chat here because of the lag or the delay. But yeah, I just threw in the tool script there and it worked. So yeah, the idea would be you do that, and then we go back to our old rendering server shenanigans. The only thing now is we need to build a lookup, which shouldn't be too hard to do. And in fact, what we'll do is let's hide these two. Go back to our LOD meshes and get this exported. So basically, I'm kind of managing two scenes at once, if that makes sense, from the same file. I don't know if you guys ever do that workflow, but this can be like our mesh library. And there's probably, you could do this a little bit more intelligently, I think, but we're gonna roll with this because that mesh key translates directly to this path, basically, right? There's another issue where we need to load the resources, right? So when you're using RenderingServer, you need to actually load the resources. So let's put a script on here. I think you would want to do this not on ready, but on init. And we could come up with a mesh lookup. We could hard type this. It's a string, and a mesh. So I forget, how do you loop? I don't know how to do all these little things in Godot. I always forget. What I want to do is I want to loop through these and extract the LODs, right? Yeah, how am I doing this? Let's go back to our scene process for a sec. I want to check something out. I want to print. I want to print this. Okay, so this is the mesh key. And you know what? I actually don't want to remove the LOD2. I need that. I need that part. I don't know why I removed that. That was silly. Because I need to know. No, I don't. Yeah, never mind. Because I'm going to generate all the LODs. Yeah. Now I know why I did that. So ultimately, I just need to look up. Yeah. Okay. So this string will get me to that mesh, basically. Okay, cool. I don't like looping through things at runtime. So we probably don't need to do this, but we need to load all the meshes. Godot loop through folder. I don't want to iterate through a folder on the user's machine. I just want to do it on dir access. Is this really how you do this? Oh God. Okay, fine. Fine. This seems so silly, but okay. Sure, we can copy the whole thing. All right, so we're gonna hard type this because and then our path is gonna be this guy. All right, let's see what happens here. We can turn this into a tool script just for testing. Yeah, here we go. So here's our files. I think this is going to be pretty easy, actually. We're just going to do mesh lookup. And then we're just going to do, we can't do a preload. We're going to do a load. I'd like to do a preload. So there's probably, the other way you could approach this would be to generate, right? You could literally use a Python script or something to generate your mesh keys where it's like building, or no, it's like 15 ruins 0 is preload, right? Then preload the mesh. And in fact, that's what we should do. You like to do this properly in a pipeline kind of thing. You would, you definitely want to preload this. I don't know why I'm going down this road. This is not really the right way to do this. We want to preload these assets. It's going to be a bit annoying, but this is definitely the more correct way. We should call this LOD0 for consistency. LOD2. And then let's get this. So yeah, I mean, like, I don't know. For those of you who've been around, who've kind of seen some of my stuff, I worked in some proprietary engine development before. We would be writing Python scripts all the time. Python stuff to like generate this little bit of text. because you want this to be available at compile time, right? You definitely, there's no reason to not preload the meshes in this case. So the other thing we're going to do is we're actually going to bring in this as a resource, right? So we've got instance data. So now on ready, we're going to, let's write a function to load scene. And this part is going to be not too bad. We call this instance resource saver load. What is it? Resource loader load. Okay. What am I doing? Isn't this just, can I not just, oh yeah, I'm overthinking this. We don't need to load it. We can just have access to the data. So for instance in instance data dot instance data, naming is a little bit questionable. Let's just print the instance for now. Let's see if we can actually get the data back out of this. We'll do ready and then load the scene. All right, let's try that. So if we do a good old reload here, there you go. So we got our data back out the other end. We have our mesh key, which is cool. And then now we just need to reconstruct our rendering server logic, basically. But I think it's even easier than this. I think it's just, you know, just gonna pull this. We're just gonna do city, load scene. Don't need that. We probably should have an instance RID. That's probably still a good idea. So we manage them here with this array. I usually like to put constants at the top and then vars here. Oh, this could be a constant, right? I think so. Yeah, to make things compile time where you can. Cool. So So this is where it gets a little bit weird. We need to do the 3 levels of LOD. So we're going to do for LOD in range 3. Each one is an instance. And the mesh is going to be mesh lookup. And then we need to just get the mesh key. Mesh key string equals instance dot mesh key. And var transform. Let's put an underscore. I think this all makes sense so far, perhaps. We don't have a scenario. We probably need that. It's a good idea. Scenario. And then the T origin. We already have the transform. We don't need this, actually. We're just going to do underscore transform. And then we can bring in these values because we already know these values are good. So let's just do that. All right, so what are we missing? Oh, yeah, no, I guess we can't do it exactly like this. All right, we're gonna change this up slightly. We're gonna make this function. Function load mesh. And then this needs This needs to be like this. Yeah, let's also pass this. What's the right way to do this? It seems kind of weird to pass this the index, but whatever. We can do that. Oh, in the scenario? Okay, fine. What is this? RID, it's just an RID, okay. Feels a little annoying to... Yeah, I don't like this. I changed my mind. I don't like this. We're going to do this. And then I think all we need to do is offload this into a function. We're going to set function, set mesh fade. Let's call it fade. Okay. And then we're just going to do something like this, instance. Okay. Cool. So we don't need this line anymore. What we need is these three, this kind of thing. I'm just kind of stealing the code because we already did all the work to know what these know what these values should be, right? So it's going to be instance RIDs I. This will be set mesh fade. All right, seem reasonable? Okay. I'm going to turn off the tool script, I think, because this is just going to cause more... well, no, that'll be all right. We'll do it in a tool script. That's okay. I'll just put this little bit of code in. Remove instances, and then on exit tree, we will remove instances. All right. So the question is, so if we hide that, all right, that was actually pretty easy. Something is not quite right. We're not getting all of our stuff loaded in here. I'm not getting all the right. Cool. All right. What did I do wrong is the question. Oh, I need to tell it what the LOD is. Duh. Should have worked. Oh. Yeah. Okay. This is broken. I'm going to be right back. I have to use the washroom. This is broken. Yeah, I know why. I'll let you, if for those of you still here, you can have a look and tell me why you think it's broken. All right, I'm back. Probably going to be wrapping up the stream here soon. I do want to fix this. This is just going to be if LOD equals 0, if elif LOD equals 1. I mean, this is not coded super intelligently, but whatever. You can find more ways to optimize this, but I think this is all right. So let's try reload. Hey, look, we have our LOD system. Cool, right? That's some pretty intense pop in there, eh? It's because this one of these is like really badly authored. One of the LODs, I think it's this set. Yeah, there's a lot of pinching in this model here. So we have the exact same code we had before, so we can throw in the fade pretty easily. Yeah. I mean, the shadows are pretty messed up, but I think we will want to tune the distances here. I don't know. Godot does some weird stuff with shadows. I mean, the geometry is not that different, and then all of a sudden, boom, the shadow line really changes. I think it's because of how the PSSM splits are configured. If I had to guess. Where are shadows? Directional light, right? Yeah, I imagine this is just because where these splits are. What if we do orthogonal? I mean, orthogonal honestly gives you less of that jarring shadow transition. So yeah, I mean, this is, I think, a reasonably good LOD solution. Once again, I'll show you what it looks like when we pop them in. But the tricky thing is this, right? If you want to do a custom fading solution, you run into a bit of a problem. And that problem is you need to iterate over every single instance in the scene and then set a shader uniform. If you want to manage if you want to do dithered, for instance, like dithered on alpha scissor, which is way more efficient. We should check that out. That's something we should benchmark right now, actually. We can do it on our bigger scene, right? So this massive scene here, it's got 62 million objects in it. What we should do is we should benchmark the transparent path. So right now, visibility range fade is disabled. And if we run this, right, so we've got this going on. FPS is very solid, right? So like I said, we're getting at least that 30 FPS boost over the node case. If we go to the visual profiler, depth prepass is 2 milliseconds. So that surprises me, actually. Render depth. I gotta check how Godot works again. I need to look at the source code. Does it always run the render depth prepass? I thought it only did that for if there was any objects that had transparency in the scene. There could be something weird going on with the material. Let's take a look. Cull mode disabled. Why we're not culling? Oh, I forgot that Blender does this. Oh man, this is just an enormous, that's doubling your poly count. Let's try this again. I don't want it to run why is it running the animation player? I don't know why it's doing that. It's not, there's no code to run it. Anyways, yeah, we got 3 milliseconds on depth prepass. And I need to do a bit of research to find out why, I guess. Render omnilight shadows, what? change to orthogonal. I don't know. I find the profiler a bit weird sometimes. Like, for instance, there are no Omni lights in this scene, like, at all. Culling is now disabled. Opaque is like, it makes sense. Our opaque pass is 4 milliseconds. We're rendering 10,000 objects, like, with no occlusion culling. So, I mean, you guys want to see, like, literally the profiler, like, what happens? These things get cut from the GPU, right? When you do this kind of thing. Right, so depth repass, shadows. All right, let's take a look. I'm looking for the, here we go. So the 3D transparent pass is nothing, 0.01 milliseconds, right? If we turn on fade, I'm curious, how well optimized is this? We're about to learn, I guess. Visibility, fade, self. So we're going to put potentially every single one of these, we're going to put into the transparent pass. Let's take a look. Clear. I mean, that is like nothing. 0.17 milliseconds to get LUD fading. I think what Godot is doing is that any object that's like outside the margins of the visibility fade, it cuts it from the transparent pass. So if it doesn't have transparency otherwise, we're getting 0.2 milliseconds of transparency, right? So that wasn't there before. But that's nothing. That is a very easy compromise to make to get LUD fading. Let's try something else. Let's try messing around with some stuff. If we turn on alpha, I imagine this is going to wreck the scene, but let's try it. No, actually. Oh, here we go. 0.5. Oh, check that out. Okay. So when you turn on alpha, it's now rendering them back to front. See that? When you try to render an opaque object using alpha, it gets very confused because now it's rendering back to front. It's expecting there to be alpha, but there's not. Blend mode mix, alpha, cull mode back. What if we disable? Yeah, I mean, it's still super weird. Back. If we depth draw mode, always. We get lots of weirdness there on depth draw, always. And we're seeing like through the mesh. No depth test. So I think what you can do is we can do on depth prepass. If we put all of this into the depth prepass, the question is there any hit? Is the real question. So we have 3.3 milliseconds. No, so Godot runs depth prepass anyways. The only question is, so just to remind, depth prepass is, I believe, anything less than 0.99 alpha gets cut. Godot depth prepass. Do they have any documentation on this? Yeah, here we go. Depth prepass. This renders the object's fully opaque pixels via the opaque pipeline first, then renders the rest with alpha blending. This allows transparency sorting to mostly be correct, albeit not fully so, as partially transparent regions may still exhibit incorrect sorting. Yeah, so anyways, there's a whole thing about alphas that, like, I think that deserves its own. We don't have any alpha materials here either, so. But yeah, enabling depth prepass does not change the GPU pipeline whatsoever. we're still at 3.3 milliseconds, right? So if you did alpha scissor, in theory that shouldn't change it either, because alpha scissor is there transparency in these textures? There shouldn't be. No, it's a JPEG. Get some interesting stuttering when we change the GPU settings there, though. But it's interesting, right? Like you don't get any, there's no cost. There's no cost to doing alpha scissor, because alpha scissor goes through, so here we go. Materials transparent, semi-transparent areas whose opacity is below the scissor threshold are not drawn, so they're just discarded. Above, it's drawn as opaque. This is faster to render than alpha and doesn't exhibit transparency sorting issues. The downside is that results in an all or nothing transparency with no intermediate. So it doesn't do any blending, right? Ideal for foliage and fences. Alpha hash. This is good for hair, I believe. Alpha scissor. Yeah, interesting. So there's lots of little nuances here. I can't remember what I started on here, but I was curious if there was something in the pipeline that was a little bit weird looking, the render pipeline aspect of things. What if we do unshaded? How does that look? Vertex shading, I believe, is still not implemented, to my knowledge. Yeah, this is just RGB, so there's no alpha here. Alpha is, let's disable alpha. It doesn't make a difference. This is kind of making me feel like I should try to do more alpha scissor in my game, just because it's so efficient. Depth prepass is pretty darn good, but this tends to mess up sorting. I don't think there's a way around that. Because you render the opaque pipeline first, that's front to back. With pixel culling, like discarded pixels, and then you render the rest of the pixels back to front. So I don't think that can be right. I think depth prepass always has that trade-off. But anyways, I'm starting to ramble here. I might end the stream soon. But yeah, for those of you who hung out, thanks for joining. You should I'll jump in my Discord too. Let me pull that up. If you I'm debating what videos I want to do next. There's like lots of stuff on the table to do. Like we could do physics server, we could do this pipelining stuff I'm looking at. I really want to look at alpha to coverage, because that's not even an option here. You can do alpha to coverage in your custom GD shader. That is the alpha scissor pipeline, so you get opaque pixel rendering, but you can get anti-aliasing around the edges because of MSAA. So that might be a really, really cool thing to investigate. I think just interestingly enough, like a lot of these things that Godot is doing is in line with AAA, right? It is in line with AAA engine dev. It's just a lot of us don't know a lot about these different little things. So I suspect if you're coming to my channel, you probably do, but who knows? Maybe other people will get something from it. But yeah, 10 milliseconds on the GPU. I guess most of that must be spent in the opaque pass. I'm still a little surprised at the depth prepass. Do we always do depth prepass? Or is it just because I started this with, I changed the fade mode? What if we do visibility fade disabled? And then run that. I don't know. I got to do a little bit more research on depth prepass. I didn't know it always ran. But yeah, same deal. 3.3 milliseconds. Transparent is 0. So you gain a little bit by turning off the fading, but not much. Godot is being really, really intelligent. It's only turning on transparency for things that are in the margins. So That's pretty sweet. I almost want to get like Clay John or someone in here just to like ask some questions about like the depth prepass and how these different things work. But I don't know. It's a lot of fun. I really like optimization. This is kind of my cup of tea. You know, they say optimization is the root of all evil in game dev, but I can't help it. That's what I like to do. It's really cool to see that when you're quite close, I don't think it's doing occlusion calling by default. Like, I'm curious why the pipeline thins out so much here. It must just be frustum calling. Occlusion calling. Yeah, it's... oh, is it on? No, it's not on. If true, occluder instance 3D nodes will be usable for occlusion calling. Does it do it by default? By rasterizing, okay, blah, 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 blah. The first step is to use occlusion calling. You'll still need to create some occluders. For a performance reason, the engine doesn't automatically use all visible geometry as a basis for occlusion calling. Instead, the engine requires a simplified representation of the scene with only static objects to be baked. There are two ways to set up occluders. Only mesh instance 3D nodes are taken into account in the occluder baking process. Yeah, I remember messing with this and I just found it didn't really work. And I guess for me, I want to focus on like an outdoor scene, so I don't think it'll be much help anyways. What's this bottom one? Servers, rendering, render RD. Where is the forward plus bad boy? Oh yeah, this is the, here we go, forward clustered, render forward clustered. I used to know where the sortation code was in here. I mean, it's only, what, 5,000 lines of code? The depth prepass sortation is in here. This does it always run? It's the thing that's tripping me up right now. What if I do a simpler scene? Oh, I just realized I put these two in the wrong place. Let's fix that. Let's drag these two. No, that's okay. I don't need that. Test scene. Well, I guess in this case, there's not much. It doesn't take much time because there's only one object. Doing the old duplicate. So there's like a wicked amount of overdraw here. So presumably the depth prepass might do something with that, but I don't know what. Okay, there we go. All right. What is triggering the depth repass in my scene is the question. That's a hilarious amount of overdraw. Hello. Oh, wow. So is this overdraw really caused that much of an issue, eh? Okay. Huh. Let's try something. I want to space them out. Yeah, okay. All right. Okay. Well, I'm probably going to finish the stream here. I definitely want to do a little more research on the depth pre-pass. I'm curious why this runs in the pipeline if you don't have any transparent materials. I wasn't under the impression that opaque rendering needed it. So I'm actually going to probably spend some time looking at the source code to figure out why that's happening. That's kind of interesting to me. And I'm curious. Well, I'll tell you one more thing I could check before I finish up. We could try just nuking the material. If we clear that. Oh, is this not? What did I just do? Yeah, I don't know, something to play around. Anyways, thank you for joining. Discord's there. You should come over and say hi. Let me know what you think about the videos and stuff. Otherwise, yeah, I'll catch y'all next time. I'll probably have some videos out in the next week. Otherwise, see ya. Nope, can't stop streaming.